Hi and good day to Madam. Today I will present our geomorphological findings from a fieldwork season conducted on December 6, 2025. We focus on the high relief slope behind the UMS campus in Kampong Sabang to study how tropical weatherings and surface runoff shape the terrain. Our study area consists of steep sedimentary slope from the Crocker formations. Because the land has been clear of vegetation, these slopes are directly exposed to instant tropical rains, making them highly vulnerable to deep weathering and rapid erosions. Next, we observe an advanced stage of chemical weathering. The iron mineral in the rock have oxidized, giving the soil its distinct yellowish-brown color. This process has turned solid rock into saprolite material that looks like soil but stay in original rock positions. We also found coal stone, which how that weathering moved from the outer joints towards the center of the rock. Moving on to erosions, without plants to protect the surface, rainwater carved small channels called rills. Over time, these rills merge to form much deeper gullies. As you can see in our photo using a student for scale, some of these gullies are more than 1 meter deep. Next, the most alarming finding is a process called undermining. This happens when vertical erosion washes away the base of the slope faster than the top. This leaves the upper layer, like the edge of a rod, hanging without support. These creatives are very high risk of the ground collapsing. For these conclusions, the combinations of land clearing and tropical weather has caused rapid erosions at this site. Without immediate stabilizations and better drainage, the area faces a serious threat of slope failure and infrastructure damage. Thank you.
On the day 2 of our fieldwork, we visited Kuarkapa in Kundasang, where we found interesting plutonic igneous rock. It is speckled and coarse-grained texture. It comes with a light grayish color with white feldspar flakes. It contains quartz, which can be seen by its glassy and transparent grain. Feldspar appear as white to pink crystal, bite-sized shiny, and brown flakes. And minor hornblende comes with fine black speckles, which is pretty hard to be seen with the naked eye since it's so small. These rocks usually used for building stones, paving blocks, and tombstone. The mineral inside the rock is suitable for construction materials like road beds and dimension stone. On the first day of our fieldwork, we went to Inam Taipan, where we did our research to identify the rock type as well as the exogenic process occur on the rock cliff. These rock cliff exhibit horizontal to semi-horizontal bedding planes, suggesting the formation of a sedimentary layer. Sandstone and shell are the identified rock from this rock cliff, where a mixed sand texture that include feldspar and minor rock fragments, and a smooth powdery clay-like texture. Jagged uneven rock surface full of joints and fractures are the result from erosion and expansion of rock due to pressure release from tectonic stress and unloading. The exposed surface indicates mechanical breakdown from temperature fluctuation and root wedging, which represent physical and biological weathering process. Minimal oxidation process which changes the rock color to a rusty hue caused by chemical weathering. Most of erosion even identified as natural erosion, which driven by gravity, water, and wind. For example, the steep hillside and sparse vegetation contributed to active erosion like heavy rain, splash, or runoff, while Rock Hill, lack of vegetation with a low soil moisture and abundant loose sediments, experienced wind erosion where the wind blow fine particles and small fragments which can wear away the surface of the rock. Based on the overall observation of the rock cliff, two distinct structures were visible on the rock cliff, a symmetrical anticline and asymmetrical syncline. Symmetrical anticlines folded upwards, showing a letter A, or small letter n. It has an axial plane that divide fold into two nearly identical halves, where both limbs dip away from the hinge line at roughly equal angle. The oldest rock is at the core, while the youngest out is at the outer layer. It able to store and channel groundwater, and the arc-like geometry of the structure make it a reliable model for oil and natural gas exploration. It contributed to the formation of the ridges, which influenced the drainage and topography. Exploring the anticline without proper service and preparation can lead to drilling failure and be life-threatening. While the asymmetrical syncline folded downward, shaping the letter U, it possesses two limbs that dip at not same angle, making one side steeper, which produces a tilted axial plane and a stable slope. The core is the youngest rock at the top. Artillery is the oldest rock. It is suitable place for drilling and mining activity as it stores oil, gas, and groundwater. This structure contributes to valley and basins formation that useful to support ecosystem and human settlement. Though it is tough to extract resource from a tilted geometry.
Hi to my fellow lecturer and my fellow friends. So right now I will talk about the first day of our fieldwork, which is about mudstone. As we can see, mudstone is the extremely fine-grained sedimentary rock consisting of a clay and silt-sized particles. And we can see that the texture of the mudstone is plastic and smooth to touch. And the grain size of the mudstone is very fine grain, class but not visible to the naked eye. And we touch the mudstone, it is soft but sometimes can be hard and brittle. The color, of course, it will be gray color as we observe the picture, and it generally mixture of a clay mineral with any olive quartz such as feldspar, mica, and can contain iron oxides, which can cause red and yellowish coloring. And it is generally too soft when to use. In the next slide, we can see that there are three types of weathering that we can observe, which is physical, chemical, and also biological. In the physical weathering, we can see there are two types, which is the thermal expansion and also pressure release. Thermal expansion can describe as the drastic temperature changes by expansion and contraction. Changes in temperature cause rock to expand with heat, and the rock will contract with coldness, which when this happen over and over again, it can cause the rock to have the structure of the rock will become weakened. And from the pressure release, changes in pressure can also contribute to explosion due to weathering. In process called underloading, when the overlying materials are removed, the pressure will release from the rock and cause the rock surface to expand, and it become a process called sheeting. The second one is chemical. The most obvious observation that we can see is the lazy gang ring. The color of the lazy gang ring that we can see is orange color or reddish orange color, which is we can call it as oxidation. Oxidation is when the sedimentary rock has contained ferrum in it, which interact with oxygen and water that cause the ferrum inside the rock to rusted. And lastly, biological weathering, which is the roots of the plant will penetrate the rock and causes the rock to fracture, thus contribute to breakdown of the rock. Biological weathering also can speed up the physical and chemical weathering by what I said just now. The roots has penetrated the rock.
Sungai Tamparali was the third station we visited on the first day of our field trip. It is one of the major rivers in Sabah and is part of a river system that is connected by several tributary streams. During our observation, we noticed that the flow and velocity varies across the river channel.
The water flows fastest along the side bank. Because of this, high energy erosion and sediment transportation are more active in this area. In contrast, the middle part of the channel has slower flow, which allows sediment to be deposited. This difference in flow velocity is mainly caused by friction between the flowing water riverbed and the channel bank. Continuous interaction between these factors results in stronger lateral erosion at the site and sediment accumulation in the middle. Based on the flow pattern and channel shape, the river has a semicircular cross-section with deeper side compared to the center, which is typical of an actively flowing river. On the opposite side of the river, the flow is lower because the channel is wider and shallower. The riverbank here are made of non-cohesive material like sand and gravel, which are easily eroded over time. This causes channel widening and lead to different channel patterns, such as meandering and stretch section. This shows that Sungai Tampurulu is a dynamic fluvial system.
On the second day of our fieldwork, we are then going to the Kampung Merakau, which is located in the Ranau Sabah. Before I talk about the sedimentary rock, I believe that this place is believed to be formation of the Trusmadi Range. Trusmadi Range is the mountain range in the interior division of Sabah. We can see that in the next slide, there's a cut slope that we already been to, and the cut slope is a man-made slope which is created when land is excavated, which is for making a road. There are also inclined layers which are sedimentary rocks. By using the superposition theory, we can see that the lower layer are older while the upper layer are younger. And the formation of sediments, we can interpret that Trusmadi formation are age Paleocene to Middle Eocene, which is about 1666 to 56 million years ago, which is made up of interrelated dark gray shale and thin sandstone. In the next slide, the type of rock that we can interpret here is the sandstone, which is the texture is quite gritty and it is color orange, and the mudstone, which is the texture is quite smooth and the color is the gray one. And we can also see that the sediment layers undergo extreme physical and chemical weathering. And next one, we can also observe that there's a quartz vines inside the rock, and it can be interpreted as such as quartz or calcite. A simple test can be made to distinguish between the two mineral, which we can pour the acid on the mineral, and the mineral, we can see that the mineral either will dissolve or not. But we can see on the next picture that there's a mineral fragment in it, and it's quite hard and we can interpret it that it is a quartz, because quartz is more hard than calcite.
Complex Sukarno was the second last station we visited during the second field trip. The main rock type identified at this location are serpentine and peridotite, which are associated with ultramafic rock. The area is characterized by a badland type terrain that developed on soft, clay rich and highly wetted material. Extensive erosion by wind and water continuously remove the surface material, producing irregular and rock landform. These hills in this area have steep slope and very little vegetation. Together with the easily wetted material, this lead to formation of the badland morphology observed at the site. Peridotite originates within the earth mantle and mainly composed of olivine and pyroxene. While peridotite reacts with water under low to medium temperature and pressure, undergo serpentinization, forming serpentine material. As a result, serpentinization plays an important role in controlling soil development. Geomorphological feature at complex Sukan Ranau here.
For our Day 2 fieldwork, we traveled to the Ranau district. Our main goal was to study the type of rock and see how tropical weathering and tectonic force has shaped this mountain landscape, especially at Station 4. So at this site, we observed a massive slope reaching up to 7 meters in height. The rock here has turned into saprolite, which is bedrock that has been chemically altered into a soil-like consistency. The bright orange and brown color are clear signs of oxidations, where iron mineral reacts with water and oxygen, weakening the rocks. Next, inside the soft saprolite, we found coal stone. These are rounded pieces of hard rock that have not fully weathered yet. This happened because differential weatherings, where some rocks, like sandstone, are toggle and break down much slower than the surrounding mudstone. This mix hard and soft materials make the slope very unstable. We also do a hand specimen. It has a propyritic textures, meaning they are large crystals, mostly feldspar embedded in the rock. We also noticed green streaks, which might a copper-based mineral. This tells us the rock could slowly dip underground before being pushed up to the surface by tectonic force. Finally, we observed that without plants to protect the soils, rainwater create rills that eventually turn into deep gullies. This leads to undermining and poses a direct threat to the terrain. So in these conclusions, Ranau high relief environments is highly susceptible to erosions, and we need better slope management to prevent future landslides. So that's all from us. Thank you.